Hi, it's Darius from IP Camera Helper. In this course, I focus on teaching as general information as possible, which would be independent from the make of the camera system or recorder you will be using for your installation. The above will let you apply the knowledge learned to any IP camera system you will encounter and properly install it and program it. Obviously, there will be some differences, but those differences will be mostly in some maybe additional features, maybe in the layout, in the way the menus are created or set up. But most of the basic settings which you have to do in every camera or recorder, they're the same or very similar. That's why this approach is the best, because there's no point for me to teach you about high vision, but then you will go to IC lead time or the Hawaii, you won't know what to do. So I may do one day course just for the high vision or IC lead time or the Hawaii. But this one, in this one I focus on as general approach as possible. I also teach basics of IP networks. I go deep enough from the point of view what we need for IP cameras and NVRs, but I'm not going to the full depth of networks because we don't need it. But see, if you want to learn that, you can do that. There's plenty of network courses, and you can learn. You can learn Cisco, you can learn in general, but in most cases, from what we do, you will not need it. Another reason for me giving those basics of networks is because most of the alarm, CCTV, and access engineers just know nothing about it, and I know that from my own experience. And then obviously this course also, I want this course to be also for people who know nothing about it, about the subject, not only for engineers and technical people. So that's why I'm giving those basics. And that's also the reason why I'm giving basic information about cameras and VRs. So absolute newbies can benefit too. What I do not do in this course, I do not teach basic DIY skills like drilling, cutting, fitting. I do not tell you how to run the cable from which side to where, and what to use to fit it above the ceiling and so on. It's just I'm leaving that to you, and I'm assuming that you have some basic DIY skills and you can do that. So for who is this course? From what I just said, for the course is for people from the industry, so alarm, CCTV, and access engineers. Obviously they will know a lot about HD, but if you don't know about IP cameras and MP systems, this course is for you. And the thing is, originally I just planned to do IP cameras, but then when I was doing that, I thought that it would be good to add also analog and HD CCTV, because there's a lot of people who just want to learn entire subject. But originally that course was planned as IP IP camera system course for mostly engineers. Obviously this course can be for people from other trades like electricians and people doing other stuff that want to learn IP camera systems or CCTV in general, as I said. And then obviously any people that want to learn new skills. So you have no idea, nothing about the subject, but you find it interesting, or you want to, set up cameras at your home or at your business without paying somebody. So you do the course, and it should really give you a good, prepare you well, I believe. Thank you. Hi, today we will be talking about video surveillance goals and DORI. DORI is a video standard defining the ability to distinguish persons or objects in a covered area, and it's not used in the same way in different countries, but a lot of it will be used in the UK, and in different forms, could be used in other parts of Europe or US. And those video surveillance standards we could divide into kind of 4 levels: detect, observe, recognize, and identify. And those standards also define our surveillance goals. So detect is the basically ability to detect if there is something there or there is nothing there. So there's general overview of the area. This will be very wide shot of the, very wide field of view of the camera, and all the objects there will be very small. The second level is observe, which in my opinion is mostly related to a movement. So you observe what is happening. Is this object moving this way? Is the person or car moving this way or that way? Another level is recognize, and that's give you much more information. You can see that's a person, you can see the colors, you can see the shape. Is a vehicle, what type of vehicle is it? Is it a car? Is it a van? Is it a truck? And so on. And then the highest level is identify, and this gives you an ability to get a very specific identification. So you can see the face, and that face will take a big part of the pictures. You can easily recognize who that is if you have some pictures of that person, or you have, for instance, a registration plate, picture of registration plate, which will be part of the usually it's taken by ANPR camera. And these are the required minimum pixel densities for each level. So the lowest is detect, it's 25 pixels per meter. And the second is observe, which is 63 pixels per meter. And then we have recognize, 125 pixels per meter. And then we have identify, 250 pixels per meter. Some of the producers have their own definitions. So for instance, Bosch or Axis will have their own definition. If I remember, Bosch has slightly different levels, and they don't have a level called observe, but they have a level called classify. And for instance, the highest level identify is around 120. So it's much lower than this. But anyway, these are certain levels which you can then, let's say you have to identify a person. You can assume, for instance, that you have 1 meter or less where the person stands, and you must have at least 250 pixels. But obviously you can have much better than that. There is an example here for a 4 megapixel camera. Obviously, if you remember 4 megapixel, we were talking obviously about megapixels in different levels. So you will see exactly what's the resolution, width and height. But in this case, you have lenses 2.8 focal length, 3.6 focal length, and 6 millimeters focal length. And for the sensor, which is 4 megapixel, and that's the camera. So, sorry, yeah, which gives that type of resolution. You can get those different levels at certain distance from the camera. So you have a detect level, for instance, for 2.8, 43 meters, observe 17, recognize 9, identify 4. So that's the minimum distance the person or object has to be to the in front of the camera to get those levels as in this slide. And there's an example for 8 megapixel. Obviously, you can see that from 8 megapixel is basically 4K Ultra HD camera. So you can see for the same lenses, the person object can be much farther. Comparing with this one here, so we doubled basically number of pixels, yeah, and We didn't double, almost double in some cases, the distance. And basically that's what it is. So these are certain limitations which should, when you trying to choose which camera to pick for which job, depending what the camera is supposed to do. Is it giving general overview? Is this camera which you can see a little bit better, like see what type of car and so on? Or is it a camera which has to identify the person? For instance, in the retail industry, you have a camera which is called ID camera. There's nothing special about that camera except that it's looking at the entrance and it's giving very close shot to that at that entrance, so you can see clearly the face of the person. And there is a monitor hanging there somewhere, so the person entering the shop can see them. It's himself or herself, and it's kind of deterrent. But the quality of the camera and the length, distance from the door and so on is set in the level that you can clearly identify the person when it enters the shop. That's how it should be done, at least. I'm not saying that everywhere is like that, but that's how it should be done. Thank you. Hi. Let's talk about camera resolution. As you can see on that big picture of the shopping center, which size of that picture is more or less 5,000 by 3,000 pixels, and an exact size of different IP camera resolutions, in general camera resolutions, you can see marked with those red frames. On the very left you can see old analog cameras, and as you can see, they are basically tiny. So the highest resolution you could get in old analog cameras, you could get so-called D1, which was equal to 4 CIF, which is 720 by 576 pixels. But if you look at current available resolutions on the right, there are multiple times of what this was. And not every camera had D1 resolution at the time. A lot of them were using CIF, and you had also VGA. VGA is the old monitor resolution. If you remember those cables, most of those DVRs and VRs I'm showing, they still have VGA cable, a possibility of connecting that VGA cable. But as you can see from that picture, resolution which you can get from VGA cable is just useless, completely useless when you talk about contemporary CCTV, because HD screen will have this resolution, 1920 by 1080 pixels, and that's basically what we are dealing with. So when you picking your camera, doesn't matter if it's HD or IP, because both HD and IP can have this type of resolutions. But you have to understand what you really are, what are you getting, and what you really need. So obviously we still can find on some old installations those old cameras. So they are being replaced as we go, and you can see the difference in the picture. Many times when I went to the customer and he asked why my pictures, when we already installed some new HD cameras there, he would ask, oh, this camera is blurred on the monitor. And then when we look at the camera, it was old analog camera, so there's no way you could blow picture from, let's say, D1 camera to HD screen. Obviously it was getting blurred. So in such a case, it's the only way to to help customers to replace the camera, to install new camera. But when you're installing new cameras, when you're deciding what resolution do you need, in most cases, this resolution, 2 megapixels, it's good enough for a lot of it's good enough for a lot of users. And but what happens, like if you look at this huge picture, yeah, and we have this huge shopping center, and when you start using high resolution cameras, although the camera may be a little bit more expensive, you will be getting much better resolution of the picture, what will give you ability to zoom in digitally into the picture. So you are recording, let's say, 5 megapixel, and you have basically everything. Obviously you would point this camera differently, probably lower. It's not exactly I just marked those frames so you can see the difference, but obviously you would frame the picture differently, because there's no need to look at the roof. But you will be interested in more details on the ground. So what happens is, when you have this size of the picture with this resolution, you can then zoom in on much smaller parts of the picture and see exactly the face of the person without losing any quality. And that's the advantage of using high resolution cameras. You do the digital zoom in, you take the part of the picture and read from that picture whatever you need to read. Obviously this picture as we have it now, that doesn't have enough depth of field of you see the focus is only on this level. Then we go farther, there's no focus. But if you have a camera with the enough depth of field, you will get a lot of you will be able to zoom in on different objects or people afterwards. But it all again depends on what you choose. So is it worth to install high resolution megapixels camera? Of course it is, assuming that you need it. In a lot of situations you may not need it, because you're just covering small narrow area, and you are close enough, or depending on your situation. But a lot of times you won't need it. But if you have a situation, then when with one camera you can cover. See, like if you would use a full HD camera, that's the full HD camera, you would need at least 2 of them to cover that area, or even more if you want to go down here. So that's the you can have one camera covering much bigger area. But there's few elements which you have to know or remember about. First, obviously this camera will be a little bit more expensive, but a lot of times price of the one high resolution camera won't be that much bigger, or will be less than 2 or 3 cameras of, let's say, full HD. Another thing which you have to remember that you must have a DVR or NVR which can handle that camera. You have to look at the parameters of your DVR and NVR if it can handle. So a lot of times you're working with already existing installation. So you have to check your DVR settings, check the type, version of the DVR, NVR, and probably call technical support from the producer of that, or if possible check it online. But a lot of times it's difficult, so you have to call the supplier and see if this version can handle this size of camera, this resolution. Then obviously if you're increasing resolution, if it's DVR. With DVR or NVR, you have to look at your hard drives. Do you have enough of them? Then if it's NVR, you have to check if your connection is strong enough. In most cases it will be, because as you notice in one of the lessons, most of the high resolution, even 4K IP camera, could be handled by the regular Cat5 cable. Most times, sometimes there could be problems there, but just looking at the numbers, it should handle easily. So there are those different aspects. Then you may be streaming that camera somewhere. Maybe the DVR is being streamed to monitoring stations, so you have to make sure that they can handle that size of camera. Their software can handle that. So there are multiple aspects that we have to check. But in general, it's really good to be able to replace the old camera for some much better resolution camera. A lot of installations will go with Full HD. Very few will use just 1 megapixel. But then some of the installations will use 5 megapixel or even 8 megapixel. I hope that helps. Thank you. Hi. Let's talk about general camera power requirements. I mean general because it doesn't matter if it's a HD, analog or IP camera. Although in IP cameras there is that additional thing called PoE. But in general, most of the cameras run on 12 volt DC. And amperage required is also very low. It's like 300 milliamps or something like that, depending obviously on the camera, but typically that's what it is. Some older cameras may require 24 volt AC. PTZ cameras may require stronger power supplies because they have motors which spin the camera around and move it around. So power supply for such a camera will have around 2 amps. But again, it depends on the make of the camera. But you can take it as a general guidance, what I'm saying now. Then you have IP cameras. An IP camera can be powered in most cases in 2 ways. So it will have its own Ethernet cable connection, through which you can use power PoE, which is power over Ethernet, which we will be talking about which we'll be talking about later, and it gives around 48 volts. Or there's just regular also cables hanging from that camera to which you can connect 12 volts. In most cases you can do both. You can do this or that. You can add the camera and connect the power supplies, or what most cases happens, you can send PoE over the network cable. But these are more or less power requirements. There are 2 main types of power supplies: box power supply and so-called inline power supply or adapter, depending really on the installation. A lot of cameras over this, which are placed on the suspended ceiling, will have those inline power adapters, which will be put somewhere on the tray, somewhere like that, and just locally fitted very close to the camera. Or you can have box power supply. But there's also another thing, and let's have a look here. It's a box power supply. Excuse me, my microphone was falling. It's a box power supply with multi-camera distributions for power. Each camera will have separate fuse. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's 9. Typically it's like 10 or 5. So let's say this would have 5 amps I don't know how much this one has exactly, but let's assume it's 5 amps in total, and you would have 10 fuses, and each would have half an amp, which is 500 milliamps, which is enough for a camera. And that's it's very convenient way of installing cameras. And I'm talking in this case HD cameras, obviously, because as I said, for IP cameras, most cases we're using power over internet, most cases. It's very convenient way because you can run cable to the camera, and you have power supply in one place, so if something happens, you know where to go to check why camera has no power. There is obviously disadvantage that you run the long cable to the camera. That depends obviously on the distance to the camera. But if it's a small shop, it's very good way to wire cameras. Thank you. Hi. Let's talk about how camera works. And if it's your camera, your camera at home which you're making pictures, is it your camcorder or is it CCTV camera? This what we see here on that picture will be basically the same. So you have your object somewhere here. There's a distance from object to lenses. These are lenses of the camera. Usually it's in all those modern cameras that are built in. There are some cameras which you can replace lenses, but most of them they have built-in lenses. And this is distance between the lenses and the sensor. So the camera is built the way that you have lenses, light is coming through the lenses, hits the sensor, and then there's electronically transmitted to the DVR or NVR. So sensor is the electronic type of equipment. It detects light and has different sizes. So again, we have a distance between the object and the lenses. Then there's another distance which is between the lenses and the sensor, and it's called focal length. And we have a field of view, which is the length of the field. It will be in meters. Let's say it could be width, could be height, how much camera can see on that distance. And using those parameters, you can calculate that if you know your field of view and you know your sensor and you know the object distance, you can calculate what type of lenses, what focal length of lenses you need with certain sensor type, size. And here are some examples of sensors. You have 1/3 of inch, 1/2 inch, 2/3 of inch, 1 inch. More than that, but in CCTV, let's say they're pretty common. And at the same time, you have sizes in millimeters, length and height, length and height, length and height. And then you can calculate, knowing what sensor camera will have. You can calculate, let's see if I have there is that. You can calculate what focal length you need, knowing what sensor size camera will have. So you have focal length, that's what we're looking for. So we're trying to establish what sort of lenses you need. You have to know the chip size in millimeters. That's what we were looking on this slide, yeah. And you have to remember that if you your object, taking the width of the object, you have to take the width of the sensor. If you're taking the height of the object, you have to take the height of the sensor. Just you have to stick to that, yeah. And so you have your focal length will be chip size in millimeters, and as I said, either vertical or horizontal, depending what you measure, multiplied by object distance and divided by object width. and you will get focal length in millimeters. That's how you can calculate it. So you must know your object or maybe field of view. Object width would be object or field of view required. Distance to the object, and if you know this, you can calculate that. And let's have a look here. It just gives it will give us a little better understanding how it works. As you can see, the bigger the focal length, the better zoom in you get. As you can see the violet ones, it's 8 millimeters, its focal length, and you can see the same size on much farther distance. See, angle view is smaller and distance is growing. So that's basically how it works. So with 2.8 millimeter lenses, that's a focal length, you're getting about 80 degrees view, and you can see at the distance, let's say 3 meters. 3.5, you get smaller, angle of view, but longer distance. So basically that's a zooming in. When you're zooming in on something, you making your focal length bigger. I mean, you're making the distance between the lenses and sensors bigger. That's how you zoom in. And that's basically how camera works. So you have all that information. It's very basic information, but it's important. Whole thing, light goes through the lenses, hits the sensor. This is transferred electronically, and depending if it's HD camera or analog camera, you're getting uncompressed signal sent over the coax usually. And when it's an IP camera, signal is being compressed and encrypted and sent over the network cable. But that part is basically the same. Thank you. Hi. What is the difference between analog, HD and IP camera? Technology used, intelligence, I mean how smart they can be, picture quality, mainly its resolution, sensitivity, ability to work with infrared, transmission, so the way the signal is sent. As you remember from that big picture of the shopping center, old analog cameras had very limited resolution. So CIF was 352 by 240, D1, which is 4 CIF, was 720 by 480, and was the max you could get. Had very low sensitivity. No, they were not good in night vision, and in those old cameras, most cases, there was no infrared built in. You had to have special lights, infrared lights, and so on. Those cameras also were not good for the outside. They required additional housing, and the heater should be in that housing, and so on. In general, on all those cameras ran on the coax RG59 and use BNC connectors. RG59 is the most common cable, but we will talk about cables a little bit later. New analog HD cameras have much higher resolution. Again, I just have a look again at this lesson with this picture of the shopping center. So you can have, for instance, I'll call it small HD or something like that, which is 1280 by 720, or full HD 920 by 1080, or even higher. You can have 3 megapixel, 5 megapixel, or even 8 megapixel cameras, which are HD cameras. In those modern cameras, they have already incorporated infrared. They have LEDs around the lenses. They have a modern self-contained design, and they don't require extra housing. Again, most of the cases, 90-something%. Again, they use coax RG59. You can use RG6 and BNC. Then use BNC connectors. As for IP cameras, the difference is mostly in transmission. So in a HD camera, those HD cameras, signal is not compressed in the camera, so it's a lot of data on that signal, and it's analog signal in most cases. We'll be talking later also about types of HD protocols, but most of them are analog. So there's a lot of data going through that RG59 coax cable, where and it's obviously there's no encryption in IP cameras, except beside the fact that you can have much higher resolution in an easier way. So for instance, you can have a 8 megapixel camera and it's all compressed and then sent over the network cable. So with different types of compression, the best one being H265 plus, you can, the signal will be still small, data will be still, there won't be that much data because of the compression. And another thing is that the whole compression happens in the camera. So for instance, you can have a 4 megapixel camera, but in the camera settings you can make it smaller. You can make it 2 megapixel. If for some reasons you cannot, your DVR can, so you can buy a bigger camera. You say, what's the point of buying better camera if you have to lower the resolution on the camera? Well, you may be buying new camera to the old DVR or NVR, which cannot handle 5 or 8 megapixel. So you will lower your 5 megapixel camera to 2 megapixel camera. But then when you upgrade your NVR or DVR, you will be able to turn it back to whatever resolution you want. So it's very handy feature that you just log into the IP camera and you can change the resolution. Again, in IP cameras, you have, as in the modern HD, you have incorporated infrared. You have those LEDs around the lenses, and that's pretty decent distance. Modern design, self-contained, no need for extra housing. And there is also something what's called PoE. Again, we'll be talking about this in a separate lesson, explaining exactly how it works. But just in this one, it's just power sent over the network cable. And then another advantage of those IP cameras is that they're using Cat5, Cat5e cable, which is cheaper than coax, and you can send also power over it. So its installation is cheaper, basically. Cameras are not really much more expensive than HD cameras. It's all very similar. Obviously, they'll be more expensive than the old analog cameras, but nobody's using those anymore. IP versus analog, HD analog. IP can get higher resolution in easy. Maybe it's not like that you cannot have HD in the same resolution, just as easier to do with IP. IP has no need for PSU because you can use that PoE. IP picture is already compressed and encrypted, so for instance, nobody can, without knowing password of the and protocol of the camera, you cannot hack into the camera actually. So where on the HD you can cut the cable, put a BNC splitter, and you have a picture, whatever. IP can be intelligent, so there are ANPR cameras, people counting. IP can be wireless. Another important feature of IP camera is that it can be standalone. So you don't need a DVR if you have no need for recording. You just have to see what's happening. It can be standalone camera. And as an example, video intercoms. You have IP intercoms with the IP camera. So basically, you're not recording, you're just viewing. Who's there? Who's ringing your bell? But IP is more difficult for troubleshooting for most of the engineers. And it is, and depending how it was installed, obviously, because if it's, you have a plan of where the equipment is and so on, it's much easier. But then I had so many installations I went to fix where nobody knew where the switches are, nobody knew where the PO injectors are. It was just nightmare. That's just this fault of original installation. Thank you. Let's talk about NVR, DVR storage. So we have video recorder, could be network video recorder or digital video recorder, and currently obviously nobody's using tapes and everybody's using hard drives, and it could be regular hard drives, it could be solid state SSD. But in most installations I was doing or working on, it's a regular hard drive. So for instance, for a small home installation where you have like 2 to 4 cameras and are not, you know, like 4K, just regular HD, 2 terabytes is okay. And those discs are not expensive really at the moment. It has changed so much. You can get it, I don't know, for $50, 50 euros, 50 pounds, such a hard drive. So it's not really expensive. So for home installation like that, 4 cameras, it's perfectly enough. It gives you good retention of the footage. For a business installation, 4 terabytes is I would say minimum, with small system with a few cameras. Obviously, again, it depends on the resolution of the cameras mostly, because we will be talking about setting up frames and frame rates and other stuff, but that's why I'm talking only about resolution at the moment, but we will be talking about it a bit later. And typical commercial installation, 16 to 32 cameras will use 2 to 6 4 terabytes hard drives, and that's enough again. But if you're using 4K cameras, 8 megapixels or a lot of 5 megapixel cameras, you may require more. That's how typical hard drive, 3.inch hard drive internal looks like. See, that's the types of hard drives we use, or you should use. Heavy duty surveillance type of hard drives. You cannot buy just any hard drive. So for instance, for WD Western Digital, it's a purple color. For Seagate hard drives, it's called Seagate Video, and it's named as a surveillance hard drive. And again, that's how it looks. Some people know exactly how it looks, some people don't. It's I would say about this also, talk about this when we'll be talking NVRs or DVRs, but in sometimes you buy DVR or NVR without the hard drive, and it's very easy to install. See those 4 screws there? There will be places where you can put a screw in at the bottom somewhere of the DVR or NVR, and you can just screw in those hard drives, which will come with those screws. And all you need a power cable and SATA cable connected. And I don't remember now which one is which, but I think that's the power of this, and this will be, no, SATA is small, sorry, this will be. Anyway, I think this is power and this will be SATA. I don't remember. I'm just remember it was small size. Anyway, DVR or NVR should come with that SATA and power cables, and you just screw that in and connect. Some of DVRs and NVRs will come with the discs, but it will ask you to initialize them. And again, you will get a message on the screen and just follow the steps. It's just a matter of clicking a few buttons. Thank you.